Alright, the following is a video for exercise 4.9. The name of the exercise is Machine and Cut Areas Using a Flowcut Operation. When uncut material remains because a tool is too large to machine certain areas, you can use a Flowcut Reference Tool operation to remove the remaining material. You select the tool from a previous operation to identify the uncut areas and then machine with a smaller diameter tool. In this activity, you will, number 1, create an operation to remove material that remains from a previous operation. Number 2, create multiple cut patterns in a single operation. Number 3, output more uniform cut depths in the toolpath. Step number 1, examine the current operations. Open NX19 Flowcut _1 setup 1. We have it. On the resource bar, click the Operation Navigator tab. To do what? In the program order view of the Operation Navigator, right-click 1, 2, 3, 4 and choose Toolpath Verify. Toolpath Verify. In the Toolpath Visualization dialog box, click the 3D Dynamic tab. Click Play. We're gonna slow it a little bit and click Play there. What? There is no blank. Okay. In the no blank message box, click OK. We already did. In the blank geometry dialog box, set the type list to bounding block. Okay. Click OK. Yep. Notice there is a substantial amount of material that remains in corners and filleted areas. Click OK to close the Toolpath Visualization dialog box. Okay, let's finish first. Let's go faster. 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 Okay, we can see there are areas that obviously this tool didn't cut because the diameter is too large or big. So we want to click OK here. Step number 2, create the Flowcut operation. The Flowcut Reference Tool operation is the operation that you use to remove material that remains after previous operations. Choose Home tab, Insert Group, Create Operation here. In the Create Operation dialog box, set the following operation parameters: type group, list equals middle counter. What the? House references, manufacturing, user interface, no, configuration, I think click OK. Okay, create operation. What? Oh no, file, references, manufacturing, operation. Okay. Create operation. Oh no. I forgot assembly tools, no, file, preferences, manufacturing, output, configuration, reset here, reset to default, okay. Home, create operation. Ah, there it goes. So we just need to go to file, preferences, and then manufacturing. And then here in configuration, we use reset to default. And then that's how we get back all the options. Okay, so we go to meal counter, and then in meal counter we need to find Flowcut Reference Tool, Flowcut Reference Tool. Flow meal multiple, flow reference tool, flow meal single. So now we have three options. We're gonna select this one. We're gonna select, I think it's this one. So we're gonna go with this one. If it's not, then I'm gonna have to restart the video. Flowcut Reference Tool, location group 1, 2, 3, 4, tool and meal, 2 inch is this one here. Geometry, meal area, method, meal finish. And then we click OK. In the Flowcut Reference Tool dialog box in the Drive Method group, in the method row, click Edit. In the Flowcut Reference Tool dialog box in the Drive Method group, in the method row, click Edit. Method, yeah, geometry. Okay, we'll see. Okay, in the Flowcut Drive Method dialog box in the Reference Tool group, from the Reference Tool list, select and meal 0.5 to 50. So we need to find optional, specify cut area, cut region, specify check, options, save, main, here. Edit? No. Okay, containment, reference tool is right here. Okay, Flowcut reference tool select. Okay, in the reference tool group, from the reference tool list, select and meal 0.5 to 50 here. Reference tool there. Okay. The reference tool is a tool that was used in the previous operation. NX calculates the bitangency contact points from the specified reference tool diameter and then uses these points to define the cut region for the current operation. Okay. Click OK. We don't have to click OK here because the interface is different. In the Flowcut Reference Tool dialog box, in the Actions group, click Generate. Okay, we use Generate. Nice. Notice how the toolpath is created only in the concave corners and fillets areas where the larger tool used in the previous operation could not fit. Makes sense. Step number 3, modify the cut pattern for steep and non-steep cut areas. Okay, in the dry method group, in the method row, click Edit. We established that that is not actual information. In the Flowcut drive method dialog box, set the following: non-steep cutting group. I think it's gonna be here, not here. Actually, because multiple main non-steep right here. Okay, so non-steep cutting group, non-steep cut pattern, C-level zigzag. Okay, the non-steep, so we're gonna click, oh, I don't see it, steep cutting, oh yeah, wait a minute, on the non-steep cutting, non-steep cut pattern, we're gonna select C-level zigzag. What? I don't even see it here. I think it's gone. The C-level zigzag is gone. I don't see it. That sucks. Steep cutting group, steep cut pattern zigzag. Maybe is a way around? I don't think so. Steep cut pattern equals zigzag. Okay. Click OK, generate the operation. What's wrong with this one? Well, we'll see what's the difference. Okay, zoom in on the part. Yeah, I don't see much difference. What if I go like this? C-level zigzag. Okay, I don't see much difference either. It says here, zoom in on the part. Notice the change in the cut pattern between the non-steep and steep areas of the part. Yeah, I don't see the change. Thanks. thanks to the fact that they change the selections. I don't see the C-level zigzag selection here. That sucks. Edit the Flowcut drag method as shown. Non-steep cutting group. The non-steep cutting group. Okay, non-steep cutting. Cut, non-steep cut pattern. C-level zigzag. There is steep cut pattern, C-level zigzag with lifts. Generate the operation. Notice the change in the cut pattern. No, notice the change in the cut pattern fillet intersection. Yeah, like right here. Okay, I see some change now. But this doesn't look like right. It's not right. Step number 4, create a more uniform cut pattern. Zoom in on the part in the location shown right here. Uh-oh. Notice the variation in the cut levels. I don't see any variation here. I don't see it. Edit the Flowcut drag method as shown. Non-steep cutting group, C-level cut levels optimize. Non-steep cutting group, C-level cuts. I don't see it. Non-steep cutting group. This is the non-steep cutting group. C-level cut levels optimized. It's not here. Step over. What the heck? Levels optimized. Maybe they made a mistake, and instead of selecting this one, we're supposed to select this one. Generate the operation. Let's see what happens. Yeah, this doesn't look the same. It doesn't look the same. I mean, it's doing it, but it's not doing it the same way. Notice that the optimized cut levels options outputs a more uniform depth per cut in the toolpath. This option requires more processing time to calculate the optimized cut levels. constant, optimized. Sucks. Click OK to save the operation. Step number 5, simulate material removal. In the program order view of the operation navigator, right click 1, 2, 3, 4. Well, before we click OK. And choose toolpath verify. Toolpath verify. In the toolpath visualization dialog box, click 3D dynamics. Click play. Okay, we'll do the blank again. Click OK to close the message. In the blank geometry dialog box, make sure the type list is set to bounding block. Click OK. Click OK to close the toolpath visualization dialog box. Close the part without saving. We haven't even seen what's doing. Why is this tool? Is this tool finishing, but also is okay? Alright, so we just now click, well, let's see. Supposedly this tool is like, when I click OK, here we're gonna go to toolpath verify. Play, OK. Okay. No. Okay, so we're just gonna do a very simple here. Bounding block. We're gonna go here like that. Okay, and now we're just going to the program and we're gonna generate everything. Okay, so now we're going here. Verify it. And now we click on play. Now we can see better what's going on. We can see how the tool is cutting the tight corners. You can go a little bit faster. And now it's doing it here. So we just say OK. And we close the part without saving. And that's it.